So in this and the following few videos, I'd like to start talking about the product rule for differentiation for matrices. Remember that for scalars, if you have two functions, f of x multiplied by g of x, and this is equal to, let's say, c, if you want dc by dx, you can say that this is equal to the first f of x multiplied by g dash of x plus f dash of x multiplied by g of x. So you should know that for scalars from your calculus courses, and now I'd like to talk about something similar for the case of matrices. The thing is, for matrices, we have a large amount of combinations for this product rule. For example, we might handle the case where we have a scalar that is a function of some matrix A multiplied by another function of the same matrix A. So this is a scalar function of the matrix A, and this is another scalar function of the matrix A, and I want to get ds by dA. So what is this equal to? So this is one case. On the other hand, we can have the opposite case. Suppose we have two matrices A and B. Both of them are functions of some parameter t. So this is a product of two matrices. This will produce a matrix C as a function of t. Now we want to get dc as a matrix by dt. So here we have a product of two matrices that we want to get the derivative of with respect to some scalar. So this is the opposite case of the previous one. So what would this be equal to? We can also have another situation. Suppose we have some alpha being equal to, let's say, y transpose x. So this is a scalar, but this scalar is obtained as the dot product between two vectors, and we can have both the vectors as functions of another vector z. Now we want d alpha by dz. How to obtain that? So this is a third product rule we might want to get. Here we have vectors as functions of vectors that produce a scalar. Here we have matrices as functions of scalars that produce a matrix. And here we have scalars as functions of matrices that produce a scalar right here. Of course, we can have many more combinations for the product rule. For example, we might want to get the product rule of the cross product between two vectors, or for the element-wise multiplication of matrices. And we can have those with respect to scalars, with respect to vectors, and with respect to matrices. And we really have many combinations. And of course, I will not cover them all. I'll cover some of them that I find to be very important for some of the topics I'll cover later in the course. Specifically, I'll cover those three cases I have written in this video, and I'll start doing that in the next video.